I hope you remember on which chapter we were studying chapter number 2, work and energy, and we had completed and we had seen till the law of conservation of energy, and now we are continuing with the free fall. Now let us see what free fall is. As the name suggests, free fall, that is any object that is falling freely, that is, it doesn't have any sort of force or pressure on that. Just imagine, or just suppose you are holding a ball in your hand and you are throwing it or you are releasing it from some height. So if you are releasing it from some height, it does not have any sort of pressure in it. You are not forcing it, you are not applying any sort of pressure, but it has some sort of internal energy, that is the kinetic and potential energy which we had studied before. Now let us see what free fall is. If we release an object from a height, it gets pulled towards the earth because of the gravitational force. An object falling solely under the influence of gravitational force is said to be in the free fall or to be falling freely. Any object that does not have any sort of force or pressure, we can't say that it does not have any sort of pressure or energy completely, and we can't say that it is free fall. Like it does not have, we can't say it like it does not have any sort of pressure on it. But if any object does not have any sort of pressure or force, but it has gravitational force acting on it, every object has gravitational force acting on it. So let us look at the kinetic and potential energies of an object of mass m falling freely from height h when the object is at different height. Let us consider or have some situations around us, and suppose that object is a ball which you are holding in your hand. As shown in the figure, the point A is at a height h from the ground. Now let us consider that at A, initially you are holding a ball at the height h and at the position A. Now let the point B be at the distance x vertically below A. Let the point C be on the ground directly below A and B. Let us calculate the energies of the object. Now let us calculate the object, that is let us calculate the energy acting upon it, upon the ball which we are holding. First, we are having three different situations, so we are going to first see when the object is stationary at A, its initial velocity is 0, u is equal to 0. As we had seen before, we do consider the initial velocity as 0 and the final velocity as v. Therefore, when the first situation is applied, kinetic energy, as we all know the formula of kinetic energy, it is half mv square, that is half mass into velocity square, and in here velocity is u. And as we had seen, in here we are not considering any sort of movement, so the velocity is definitely 0, and the potential energy as usual is mass into gravitational force into height. So if the kinetic energy becomes 0, so the only energy which is applied in this situation is the potential energy. So total energy which will be equals to the potential energy, that is mass into gravitational force into height.